It would cost a significant amount of money to do this, but I mean, you can't just deploy a system that's going to burn a lot of fires and not, see how do I extinguish the wrong ones. I mean, I just find it irresponsible to only deploy positively in that you just sort of go ahead and move fast without deploying the other two things, which is how do I understand what I'm deploying? What's the error pattern? How do I safeguard against the issues? And given how much sort of money is floating around in tech, Apple's like what, sitting on $150 billion? It's the kind of stuff they can do, and it's the kind of stuff they should do. And now, of course, if you did it that way, it doesn't become as attractive for a corporation because it's not as cheap anymore. And part of the speed with which AI is being deployed is that it allows you to scale up certain kinds of decision making without paying humans to do it, who are expensive. But it comes at this great cost that we're transforming gatekeeping in our society and turning it over to decision making systems that, I repeat, we do not understand their behavior anywhere near the depth that you would need to responsibly deploy them. So the problem isn't using AI. There could be lots of benefits from AI. The problem is going so fast at deploying it without thinking through and safeguarding for the pitfalls that we've already seen emerge again and again and again. And we know that there are a lot of subtle ones that haven't even been studied that we're gonna encounter eventually. And then people are gonna ask, wait, why didn't we think of this before? And that's what I'm saying. We're here, it's early enough. Let's put resources into thinking through these other dimensions.
Perfect. Well, thank you very much. And is there anything I kind of didn't prompt you on?
I'm thinking, and I just realized I've been looking at the phone. I should look at the. I hope the video's fine.
Yeah.
I'm kind of short, so it might work.
Yeah. And the main thing is that you not look in the camera.
Right, I'm not looking at the camera. All right, let me think. Why don't you ask me? I keep referring to machine learning. Why is that a different thing? Because that's kind of a subtle thing that people.
How do you distinguish between machine learning and other aspects of AI?
So one thing that's least understood, I think, about the current AI is that a lot of it comes from this method called machine learning or deep learning. The method's been around for a while, and it was thought that it wouldn't be very powerful because it was around in the 90s. Well, it turns out the method just needed a lot of data to be functioning well, and that's where the big data thing comes in. So what you essentially have is computational systems that can churn through a lot of data and classify things, right? So they can churn through a lot of people's social media data, for example, and then using some previous examples, they can say these people will be more productive employers. These people will be more productive employees than these people. So when you have a machine learning system that can say hire these people compared to these people, using these systems, computational methods, the part you're missing is why. In the past, you might have said, hire people who have high GPAs. Now, that's not a great method, that has pitfalls, but at least you knew what the criteria was and you could try to go tweak it. And it might not even be great, but you knew what you were doing. Like you're hiring, let's say you were hiring based on their college where they graduated from. Once again, that's not a completely fair thing. A lot of great people don't have the degree, so maybe you do need some other method. But you knew that was the pitfall. Whereas with these machine learning systems, unlike old style programming, you're just throwing a computational thinking machine. Let me put it this way. You're just throwing lots of data at a computational thinking machine. And you're saying, here, learn from this data and classify using examples I gave you before. It learns to classify, but it cannot tell you, and you cannot tell by looking at the program, looking at the data, you cannot tell why it's classifying the way it's doing. So if it's picking up on subtle hints that's not visible to any human detection, that these people are slightly more prone to depression, that these women are more likely to have children in the next 5 years, that these workers are more likely to be slightly more rebellious. You don't know that it's doing this because it's machine learning. It's non-transparent to you. And I find it really worrisome to shift decision making at large scale to these systems which are going to be good at optimizing on the variable you asked it to train on, like productivity, without considering what is it able to tell when it's doing this classification using all this big data that has been gathered about us that we as humans aren't seeing. The whole point of them being used is that they're seeing subtle things that aren't apparent to us. And I would like to better understand what those are before making that kind of a system the gateway to everybody's first job and a life-changing decision maker. I think we should understand this better.